Hello and welcome to this video for Chemistry 20 in the stoichiometry unit. We are going to today look at what we call gravimetric stoichiometry. Well, gravimetric stoichiometry is just another way of saying we're going to be dealing with masses. Now, anytime in chemistry you're dealing with masses, because in chemical reactions we don't directly have mass information to use from one substance to another, we're going to need to also have molar masses, okay? Because in a balanced equation, balancing coefficients tell you the mole ratios. So we need to always convert things into moles, okay? So that means we're going to be using the formula that we learned back in Science 10, moles equals mass over molar mass. Now, molar mass is the capital M. Remember, you find that by using the periodic table. Little m is the mass in grams. So there are some steps to help you remember what to do in a gravimetric stoich question. So the first step is to write the balanced equation. Make sure you include states, make sure you have balancing coefficients, write down all the information given. It's also useful in this step to identify the wanted and given, like we did in the last video, and find the molar masses of them. Because like I said, you're going to be using their molar masses in the calculations. So you might as well find those right off in the beginning step, okay? Then you're going to find the moles of your wanted using the formula mass over molar mass. Sorry, moles of given. It says that right there. Find the moles of the given, and we can even put N of the given here, using the mass of the given over the molar mass of the given. So this is everything to do with the given species. Then you're going to apply your mole ratio like we learned in the last video, okay? In order to find the moles of your wanted, you take the given moles that you just calculated in step 2 and multiply by the balancing coefficients, the one in front of the wanted over the one in front of the given. And then the last thing is you're usually looking for the mass of the wanted. So to find the mass of the wanted, we can write that as mass of my wanted. I'm going to use the moles of my wanted that I just calculated in step 3 and multiply by the molar mass of the wanted that we calculated back in step 1, right? Because remember in step 1, you're finding the molar mass of both the wanted and the given. So you're going to have two molar masses in these calculations. So it's important you kind of arrange it so that you know when to use which molar mass and you don't mix them up, okay? So in this step, we're dealing with the wanted. All right, so these are your 4 steps. Memorize them, write them down whenever you're doing a question so that you remember these are the steps that you need to do for gravimetric stoichiometry. And in fact, all stoichiometry calculations that are going to involve solutions and gases later will involve these steps, just some variations to it. So it's good to remember these steps. Okay, so here is my first example. Now, this is a complicated reaction, so you're given all the information of it. It doesn't always fit our 5 reaction types. It says iron is produced by the reaction of iron 3 oxide. So that means iron with a 3 plus, oxide is oxygen with a 2 negative, is reacting with carbon monoxide. Okay, that's a molecular compound. So we are given the formula with its prefix name. So iron 3 oxide would need 2 irons to get to +6 and 3 oxygens to get to -6 to make the ion charge balance. Remember, whenever you have ionic compounds, you need to make the ion charges balance. So that would be Fe2O3. Now, it's not saying anything about this happening in a solution, so we can assume it's not happening in a solution. So our ionic compound is just solid. Now, carbon monoxide is a gas. And again, the mono means there's 1 oxygen. No prefix on the first element means there's 1. We are producing, so our products are iron. Iron is just Fe solid. And carbon dioxide, CO2 gas. Okay? Now, to balance this one is a little tricky, and so sometimes when you're balancing it takes a few tries, so always use pencil when you're doing this. Okay, so for example, I'm like, okay, I have 2 FEs. I'm going to put 2 in front of that FE. O's, I have 3, 4 on the reactant side, only 2 on the product side. So if I put a 2 here, that'll give me 4, but that'll give me 2 carbons. So if I put a 2 here to get 2 carbons, now I have 3, 4, 5 oxygens. That doesn't work. Okay, so when we get into these situations, I like to play around. 2s didn't work. Let's try 3s. They both need the same coefficient in front of them to make the carbons balance because there's 1 carbon in each of them. Okay, so if I try 3s now, I have 3 carbons on both sides. Oxygen, I have 3 plus 3, so 6 on the reactant side, and 3 times 2 is 6 on the product side. So they balance. Okay, the 2 in the Fe was good, and now I don't need a coefficient in front of that compound, or I could put a 1. So that's how to balance those little more complicated reactions. Sometimes it's just guessing and trial and error until it works. Make sure you always use the lowest whole numbers or decimals like we talked about in the last video for hydrocarbon combustions. Okay, now let's identify our wanted and given and find their molar mass and write down all the information we have. And like I said, I'm treating this like a chart. The reaction is like the heading of my chart. Everything to do with each substance, I'm going to write underneath of it. So the question is asking what mass of iron 3 oxide is required. So I want to find the mass of the iron 3 oxide. I'm going to find the molar mass right now because I'm going to need that in a gravimetric Stoich calculation. Okay? Anytime you have mass, you need to find molar mass. When you're finding molar mass, you don't use balancing coefficients, but you use subscripts. Okay? So that's only a 1 in front of it, but if it was a 2 in front, I wouldn't use it. But I do have a subscript 2 and a subscript 3. So I'm going to add 2 irons, which are 55.85 plus 3 oxygens, which are 16. I like to do this in my calculator in one step. I'll show you what I'm doing in my calculator. I'm doing 2 55.85 plus 3 16s. Okay? Do that all in one step, and there's less chance of making a mistake. Remember, your units for molar mass are grams per mole. Okay? You don't have to show the calculation of your molar mass, but if you like to write it down, that's definitely fine. But I don't expect my students to show that. So we want to find the mass of the iron 3 oxide required, and we are being given that we are producing 1,000 grams of iron. So my iron product is my given. Its mass is 1,000 grams. Notice how I'm writing that under my iron. The molar mass, again, balancing coefficients don't count. There's just a little invisible 1 after my Fe. So I have a molar mass of just the iron, which is 55.85 grams per mole. Okay, and that's it. The carbon monoxide and dioxide are irrelevant in this question. So that's step 1. I've written down everything I'm given and looking for, my molar masses. I've labeled my wanted and given. Always label your wanted and given. So now, I'm going to erase that so I have a little bit more space here. I'm going to find the moles of my given. That's step 2 with mass over molar mass. So the mass was 1,000 grams. The molar mass is 55.85 grams per mole. Now in other videos I've explained this before. When you have the denominator in the denominator of this bigger fraction, that actually makes the mole go up there, just for unit analysis purposes, okay? So what that means is I have the mole on top. So the grams cancel and I'm left with moles. Now when I get this answer, I'm not rounding it because it's not my final answer. So leave it as a big long number. If you can't store it in your calculator to use in the next step, write the whole number down, okay? If you can, though, I usually write a few digits and then put ... reminding myself to continue using this unrounded answer in the next step. So that was step 2, finding the moles of your given. Now step 3 is to find the moles of my wanted. So I go over to under my wanted, I write the given moles that I just had, unrounded, and now I'm going to multiply by my coefficients, wanted over given. In front of my wanted, there's a 1. In front of my given, there was a 2. Okay, so I'm going to multiply by 1 divided by 2. So we get the moles of our wanted to be 3.13 so on moles. Now I can move on to step 4, where I find the mass of my wanted by taking the moles of my wanted that I just found and multiplying by the molar mass of my wanted, which is written up there. Okay, so I take my 3.13, again, unrounded answer. I'm going to multiply it by 159.70 grams per mole. So this mole is technically at the bottom to cancel with that mole, and we'll be left with grams. So the unrounded answer times 159.70. We get, I feel like this is the wrong answer, 500 grams is the exact answer. Did I do that right? I didn't. Oh, I just see my mistake. I did not divide over here by 55.85. Let's fix that quickly. Always double check your work. Okay, so 1,000 divided by 55.85. There we go. 17.9. Those of you following along may have been like, where did she get that answer? 17.9 unrounded times 1 over 2 is 8.95. Now 8.95 unrounded times, now I do 150. Yeah, I mixed up my molar masses. That's why, like I said, it's really important to always follow really carefully when to use which molar mass. Okay, so now my answer is 1,429.72 so on. This is a mass, so it's grams. Now to figure out my sig digs for my answer, I look back again at the question. There was 4 total digits in my mass, so I can keep 4 total digits in my other mass. That means I'm not cutting off the decimal, so I don't need to put it in scientific notation, but I am looking at what digit I'm cutting off after the last digit I'm keeping, which is a 7. So it is going to round that 9, and because that's a 9, it is going to round that up. Okay, so your final answer should be 1,430 grams. All right, 1,430 grams. And that again is your stoich. So if I were to label the steps here, this was step 1. Write the balanced reaction, identify your wanted given, write down the given information, calculate your molar masses. This here was step 2, find the moles of your given. This here was step 3, find the moles of your wanted. And this final step down here was step 4, convert that wanted moles into its mass with moles times molar mass. We have one more example, and then that's it for gravimetric stoich. Let's look at our next example. This is another complicated reaction. Okay, so we're given all the information of it. We have the decomposition of something called mineral malachite, and you're given the formula for that compound. We're going to have to find the molar mass of that compound properly, so that's going to be fun. Cu2, CO3, OH2. Solid. It is decomposing, so that's my only reactant. It's decomposing into copper 2 oxide. That's an ionic compound, so I have to balance my ion charges. Copper has a 2+, oxygen has a 2-, so I just need one of each. Again, this isn't saying anything about happening in a solution, so I'm going to assume there's no water here, and so my ionic compound is just solid. Carbon dioxide is CO2 gas, and water vapor is also produced. We are given all the products here, right? We're yielding, which means we're producing copper 2 oxide, carbon dioxide, and water vapor. Now let's balance this reaction. Okay, I have 2 coppers in my malachite and only 1 in my product, so I'm going to put a 2 there. Now the rest of it, I'm going to have to break into individual elements. Sometimes when you have polyatomic ions, you can leave them as a polyatomic ion and just balance them as a whole thing on each side, but they're not staying as polyatomic ions, they're breaking up. So carbons, I have 1 carbon here because there's no number. Don't ask me why that's in brackets, that's just the way they wrote the formula, but there's an invisible 1 there, so there's only 1 carbon. I have 1 carbon in my carbon dioxide, so that looks good. Oxygens, I have 3 plus 2, because this 2 goes with everything in the brackets. So I have 5. On my product side, I have 2 plus another 2 plus another 1. So that's 1, 2, 3, 4, 5. So those balance. This is a good question to practice balancing. And then my hydrogens, again, this 2 goes there. So there's 2 hydrogens and 2 hydrogens. So putting the 2 in front of the copper 2 oxide was all I needed to do to balance it. Okay, so now I like to put 1s because I'm using balancing coefficients in my calculation part of the question. So I like to see what they are, and I like to put 1s to know. If there isn't a number, it's a 1. Okay, now let's figure out our wanted and given and do all of our molar mass calculations. It says what mass of copper 2 oxide is produced. So I want to find the mass of my copper 2 oxide. Okay, I'm going to right now find its molar mass. Again, the balancing 2 doesn't count, so it's just 1 copper. Copper is 63.55 plus 1 oxygen, which is 16.00. I get a molar mass of 79.55 grams per mole. Do not use balancing coefficients in finding molar mass. Okay? I am given that we have a mass of 1.00 grams of that big crazy compound. Let's find its molar mass. Okay? So we have 2 coppers. Copper is 63.55. So remember, I'm going to actually show this again. To find my molar mass, I have 2 coppers, which is 63.55. I have 1 carbon only in that compound. So then you can put a 1 or you can just put the 12.01. Oxygens, I need to add up all the oxygens. Remember, there was 3 plus another 2. So there's 5 oxygens, which are 16.00. And hydrogens, this 2 goes with the hydrogen. So there's 2 hydrogens, 1.01. Okay? That's how you can put this all in your calculator in one calculation. Saves some time. Less error. Usually when you do it this way, we get 221.13 grams per mole. Now, before I move on, I'm just going to make sure that's right. Yes, okay, perfect. All right, I'm going to erase this. Actually, I'll just leave it. It's not a big deal. Okay, so there is step 1. Writing reaction, identifying everything. Now, step 2 is to find moles of my given with mass over molar mass. Make sure I use the right molar mass this time. 1.00 grams divided by 221.13 grams. Again, the per mole ends up going on the top. So my grams cancel, and I'm left with moles. 1 divided by 221.13 gives me 0.00452 so on moles. So that's the moles of my given. Now I move them over to find the moles of my wanted, 0.00452 so on, times wanted over given. In front of my wanted, there's a 2. in front of my given, there was a 1. Okay, so I'm multiplying this unrounded answer by 2 over 1. We get an answer, moles wanted equals 0.00904, so on moles. So that's it for step 3. And then step 4 is now to find the mass of my wanted with moles times molar mass. Okay, so 0.00904, remember again unrounded. My molar mass, this time I'm using the molar mass of my wanted, which is 79.55 grams per mole. So the moles cancel and we're left with grams. So that unrounded answer times 79.55 gives us an answer of 0.71948, so on, grams. Now sig digs, there are 3 digits in the question, so leading zeros don't count, which means I'm going to cut it off after the 9. Now I'm cutting off a 4. A 4 does not round the 9 up, only if it was a 5 or more. And some students say, well, there's an 8 after it, so the 8 rounds the 4 to a 5. No, we don't care about any of those digits. We're only looking at the last digit we're keeping and the first digit we're cutting off, okay? So it doesn't round up. It would be 0.719 grams to 3 sig digs. Okay? Make sure that's the right answer. Always, when you're doing a test, quiz, always double check your work if you have time, right? Double check your molar mass calculations. That's usually where most things go wrong if you're getting the wrong answers from molar mass calculations. So always double check those. Make sure, like I made the mistake, don't use the wrong molar mass with the wrong part of the question. And that's it. That is gravimetric stoichiometry. Okay? Thank you very much for watching this video.